Hello, I'm Wolf, and you're looking at my third build of a chaser circuit for my model kit hangar deck landing lights. And did some slightly different stuff on the third attempt here. Actually, this board came out the way I really like it. It wasn't what I expected, but I think I'm actually going to use this one in the model kit. For those of you that just want to get past this, I'll go through the nuts and bolts. First of all, you're actually watching two things happen at the same time with this build. You have your 7 LEDs that light and latch, and then an 8th LED that comes on at a separate clock, and then the whole thing shuts down and starts over again. And it uses the 74HC164 IC again, which is a serial in, parallel out. But this time, instead of clocking with a 555, it's clocking with a package that's actually 6 inverters in one, and it's called a 74HC14. And RonH over at All About Circuits turned me on to this design, and so I played around with it just because I threatened to do it, and I'm glad I did. It worked out great. Anyway, let me turn this off for now, and I'll just show you a RON circuit. In case you want that, you can do a screen capture there. Let me zoom in there for you a little bit. And for those of you that are like brand new to this, like I was a few months back, the 74HC14 isn't visible on the screen. It's kind of like common practice to spread the inverters out around the schematic. And you can see, like, up here's one component of it, another one there, and a third one there. And then he's got listed 3 that aren't even used. And what an inverter does, and I'm no expert, so no one even explained this to me, but basically the way I take it is it like shifts the polarity. It inverts the polarity, so it gives you a way to like oscillate. Right up here in this corner, that's like the same equivalent of the 555, which is really cool. You can build it with 3 simple components. You can actually buy the inverters separately, but if you need multiple ones, it's better to just get a package, because a separate inverter will have 5 pins. You know, the 74HC14 is a 14-pin IC. 12 of those pins are because of 6 inverters, and then you need a power and a ground to the IC. And then after the schematic, I tried to do this in Proteus and it wouldn't run at all. It was one of those cases where the software worked but the hardware wouldn't. Or in this case, the hardware worked where the software wouldn't. But I was actually fooling around with another schematic that Ron gave me. And while I was breadboarding it, I just went off and went, well, let's see what this other thing does. It didn't work in the software. Maybe it'll work in the hardware. And as you see, it did. And I liked it, so I stuck with that one. So after this and the breadboard, then I did the layout again. And you got your 74HC164 here, which is kind of like that 7014 Johnson's decade counter, but it's a lot more versatile. You can do a lot more stuff with it. And then this here is the other, sounds very similar, 74HC14, and it's 6 inverters and a power and a ground. And that's my layout for that. And then of course I did the same thing and mirror imaged it so that while I was soldering I could see from the back side of the board how things are working. And then let's see, the only other things I did differently on this build, going back to the board itself, are I used this brown board instead, which is like a cardboard. I don't know, it's got some kind of resin or some kind of other material mixed into it. It's not that flexible really, like cardboard would be. And just the like brass eyelets around the holes. It's a lot cheaper quality. I mean, there were like holes that didn't go all the way through and stuff. You know, you have to like drill them out if you need to use them. But I like it because it was so easy to cut down to the size you want. And I was like restricted on space. So even on the previous build, I took one of those hard green plastic boards and I wanted to chop off like almost half of it. And you know, that wasn't easy to do. I treated it like a piece of plexiglass or even glass, where I'd score both sides with an X-Acto knife and then put it on a sharp corner and break it. And it took a lot of time to do that. But with this cardboard stuff, you know, just a couple scores on either side and bang, you're done. That was really quick. The quality's lower, but it's dirt cheap, and I think I'll be like leaning towards that from now on. Anyway, only other thing I can add is, wow, I'm glad I'm done with this. This detour took me a lot longer than I thought it would. It's been like month after month since I've touched my model, actually. But I'm glad I took the time to do this. It's, I learned a lot of basics in a short amount of time, I think. And I learned about, you know, a couple forums out there where you can just go and ask guys questions, and they'll get you set up in the right way to go. So hopefully the next video I make, I'll be gluing plastic or painting or something, aside from making LEDs light up and down. Anyway guys, thanks for watching and happy modeling.